Okay, let's move on to question 9. In this question here, we want to discuss a theorem called Fermat's little theorem. And I will just say what it says here. It says that if you take, okay, let me get on to the next screen. It says that if you take any integer, say 6, and take any prime number, say 11, then it says that if you take the number 6 to the power of 11 minus 1, which is 6 to the power of 10, it says that when you divide this number by 11, the remainder is 1, always. In other words, this thing here is some multiple of 11. We'll call it Q for quotient. And the remainder is 1. So it's a multiple of 11 plus 1. Okay. And this works for any integers, any numbers and say P, prime P. Let's take a simple example where the 6 to the power of 10 is quite big. So suppose we take 4 to the power of 6. We'll make it 4 to the power of 7 minus 1. Okay, and this is 4 to the power of 7. And it says that if you, I'm sorry, 4 to the power of 6. It says that if you divide this by 7, that one, then the remainder is 1. If you try 4 to the power of 6, what is 4 to the power of 6? Well, 4 to the power of 6 is 2 to the power of 12, so it's 4096. Okay, and if you divide this by 7, 7 goes into 45 times. 7 5 is 35. 7 goes into 59 8 times. 8 7 56, remainder 3. 7 goes into 36 5 times. And 36 35, so the remainder is 1. So in this particular case, this is equal to 7 times 585 plus 1. 7 times 585 is 4095, and you add 1 to it, equal 4096. So this is your 7q plus 1. All right, so this is Fermat's little theorem. It's a very powerful theorem, and we are not in a position to prove it right now. So the problem says, find the remainder when 7 to the power of 30 is divided by 31. All right, so if you take A now, 31 is a prime. And by the way, I should have said that when you take 6 to the power of P minus 1, this, your base 6 must not be a multiple of 11. I can't have 22 to the power of 11 minus 1. It doesn't work. Right? Your base cannot be a multiple of 11. So a 31 is a prime, and your base is 7. And 7 and 31 are co-prime, which means that 7 and 31. Yeah, what we really want to say is, so 31 is not a multiple of 7. 31 is not a multiple of 7. So therefore, Fermat's theorem says that 7 to the power of 31 minus 1 is equal to, here you got 31, a prime. 31 is a prime. 31 times the quotient plus 1. So therefore, 7 to the power of 30 is equal to 31 cubed plus 1. And the question is, find the remainder when 7 to the 30 is divided by 31, and the answer is 1. This is exactly Fermat's theorem. Right? So it's a multiple of 31, this, and 1 more than that. So when you divide it by 31, you get the remainder of 1. Okay, so that's the first part was quite easy. The second part, it says here, so there it is. If P is a prime and A is in any integer not divisible by P, so A must not be a multiple of P, then A to the power of P minus 1 is divisible by P. I put it as A to the power of P minus 1. When you divide it by P, the remainder is 1, which is the same kind of a thing. So when you subtract 1 from this, it becomes a multiple of P. And if you think about that, it's all these things are the same thing. So if you look at this one here, you've got find the remainder when 3 to the power of 101 is divided by 303. So here, again, if you take 3, 101 is a prime, and 3 is not a multiple of 101, obviously. So according to what we have been saying here, this is equal to 101 times the quotient plus 1. And this is Fermat's theorem. Oh, I'm sorry. This is 3 to the power of 100. It's 101 minus 1. So 3 to the power of 100 is equal to some multiple of 101 plus 1. And this is Fermat's theorem. Now, when it says here, find the remainder when 3 to the power of 301. Okay, so I have to multiply this by 3 to get that. So 3 to the power of 101 is 3 times this. And that is 303 Q plus 3. All right, so what does this say? This is the remainder when you're dividing by 303. When you divide this by 303, then 3 to the power of 101, then the remainder is 3. So that's exactly the answer. Find the remainder when this is divided by this. The answer is 3. You see, generally, if you have n is divided by m, and there's a quotient, the remainder is r, then n is equal to this multiple plus r, but this remainder is always smaller than n. Right? Whenever you dividing by something, you want the remainder to be smaller than n. Yes, you are saying how many m's go into this, and the maximum number of m's is q, and then after that, the m does not go into the smaller one. So this r must be less than n. I'm sorry, r must be less than n. All right, it could be 0. It's a positive number, which could be 0. If r is 0, then n is a multiple. There's no remainder. The remainder is 0. So the whole theorem of remainders is very, very important. And if you want to know more about it, you must go and check anything about congruence arithmetic. This is called congruence. Geometry, you got congruence means a certain term, but in algebra, this is really numbers. It belongs to number theory, congruence, arithmetic, not geometry, arithmetic. Just Google this and you can learn a few things. Or if you want, you can look at my book, 1000 Olympiad Problems. And you'll be able to find that in the SAMF website. And there I've got a whole chapter on congruence arithmetic. It's a very, very powerful tool. The whole business of division and finding remainders. Very powerful tool to answer all kinds of questions regarding numbers, natural numbers, 1, 2, 3, 4, and so on, and even negative natural numbers, the integers. So, and the subject who deals with integers or natural numbers is called number theory. See, it's called number theory, and it's a very powerful section of mathematics. So if you want to know something about that, you can Google it, AI it, and see what you can learn from it. Okay. So Fermat's little theorem is an important theorem in number theory. Okay, let's get on to the next question. Okay, this is the solution that I had. And have a look at that. Let's get on to question 10. Now, question 10 reads as follows. In the diagram below, triangle FGH. Okay, I wouldn't read it. I will tell you what's going on here. You've got a triangle, and you've got a point here, and you're drawing lots of lines like that, and these are the areas which are swept out by these lines. So the area of this triangle FJ, what is I, right, is 4, and so on and so forth. So these are the areas. Now, just using this information, you're asked to calculate the area of IKH. So IKH, this IKH, and you're asked to find the area of that. So let's just identify it. So this is the area that you want to find. Okay, knowing these other areas, 4, 8, 12, and 8. Okay. Now, there's an important result that we have to use here. It's a very simple result, but very powerful. And if we use that, we'll be able to get to the answer. And the result of this theorem is the following. If you take a random triangle, and if you draw from the vertex, if you draw any line, then there are two ratios that are equal. If suppose this line splits this line here into two parts, M and N, and the areas of these are A and B, then it turns out that the ratio of M over N is the same as the ratio A over B. Right? And the proof of this is extremely simple. that A over B is the same as M over N. And the proof, I can give it to you straight away. It says it's the following. The area A is the area of a triangle. And we know the area of a triangle. This is half base times height. Now, area A is the base is H, M, times the height. And the height will be the perpendicular height from that to this base. And if I draw it, it's actually this one here, the perpendicular height. So the area of triangle A is base times the height. But the area of triangle B is the base for triangle B is half N, but it's got the same height, you see. That's the nice thing about these two triangles. They've got the same height. I can use H again. And then if the halves cancel, and the H's cancel, and you're left with M over N. Okay, so that's a very useful fact. Now, that is what we are going to use in this problem. I need to find out the area of this triangle here. It's the area of IKH. And the area of IKH, now you can see that this thing here, if you look at this triangle here, you can see KI is coming out from this vertex onto this. So you have the same situation here. So I can put this area of IKH over area of KIF. KIF. So the area of this red triangle over the area of this triangle here, right? It's equal to, it's actually equal to 8. Okay, we know exactly what the area is, but it's the same as IH over IF. All right. Okay, I'm going to remove all these colors here now. Remember, we want to work out KIH. I've got it here. So let's just remove this to see what we are doing here. Like KIF is 12. So I've got the bottom part is actually equal to 12. There it is. KIF is 8 plus 4. So I can replace the denominator there by 12. Okay, so that is equal to IH over IF. But now IH over IF is actually equal to, if you look at IH over IF, and you look at the large triangle, you can see that GI divides this into the ratio IH over IF. And that's the same as 8 over this area here over the entire, over this area, right? Because GI divides this large triangle into two parts. So you got 8 over this area here is 12 plus 8 plus 4. Right? And that is 8 over 24, which is 1/3. So straight away now you got area of IKH is What over 12 is 1/3? It's 4. 4 over 12 is 1/3. And if you want to calculate it, you just cross multiply and solve. So the area of this triangle is 4, and that answers this question 10. All right, so let's get on to the next question. And there it is. You see right at the bottom, the area of IKH is indeed 4. All right, let's get on to this question here. Okay, we have to read this question carefully. A cylindrical glass 8 centimeters high. So there's your glass. It's 8 centimeters high. Right? As a circumference of 12 centimeters. So right round the circumference here equals 12 centimeters. Right. Now, on the inside of the glass, 2 centimeters from the top is a drop of honey. So you can see on the slight dot here, right? And you got a little ring here. It means this is 2 centimeters from the top. And on this circle here, which is 2 centimeters from the top, there is a little drop of honey. Now, on the outside of the glass, okay, so you'll see I've got another picture here on the outside of the glass, 2 centimeters from the bottom. You've got an ant. All right, so this is on the outside. So you can see it. So there's a circle here, and there's 2 centimeters from the bottom. But it's on the outside. This ant is sitting on the outside, and that honey is inside. But you can't deceive an ant. That ant will know that there's honey inside the thing there. Somehow these little guys can identify anything that is sweet. So what goes on here? So what is the length of the shortest route from the ant to the honey? So the ant is, but there's one important thing. On the opposite side of the glass is an ant. So the ant is, when you say opposite side, it means that if you draw the diameter of the circle, the diameter must be opposite. And then this thing, the honey is vertically above that diameter. Okay, so this ant now it makes its way from the outside, it goes to the inside of the glass, and you want to know what is the shortest route from the length from the ant to the honey. And this is not an easy problem. I must admit that I took a long time to solve it. I'm not even sure whether I did solve it. But this diagram here explains everything. So what you do is you take this cylinder. The shortest distance is always a straight line. So I want to somehow draw a straight line from the ant to the honey. But you can't draw a straight line on a curved surface like this. So what you do is you open up this cylinder, as if you are cutting on the side here. Cut it and open it out, and you'll get a rectangle. Okay, so when I open this thing out, and open it out to make it flat on the sheet, then the inside comes to the top and the outside is at the bottom. Okay, so So here, I've got the inside here. That's what I see. So I've got the inside. When I open it out, and the you can see the height of this. There's your 8. That's the height because I've opened this thing up. This is the inside which you're looking at. And when you open it out into a rectangle, then the side of the rectangle just becomes the circumference of this because you're opening it out. So this is the circumference, which we were told is 12. Right. Wow, what happened? My thing is disappearing here. Why is my writing disappearing? Oh, because I chose the wrong pen. All right, so it's 12. Okay, you can see 12 here. So this length here is 12. So I've just explained what this top rectangle is. It's the inside. But somehow I want to bring in the outside because the ant is actually sitting outside. So what I do is, so the inside is taken, but we're turning it upside down. We open this thing out and turn it upside down because the honey now, here is the honey. The honey is here. It's 2 centimeters from the top. So you can see the 2 centimeters and the honey is here. So in other words, I'm turning the inside upside. So this is the, oh no, the honey, yeah, is on the inside. Right. Now, on the outside, now from here to here is 2. And now I'm going to go from the top of this rim here. I'm going to go on the outside to the end. And the best way to do that is to go uh, uh, a straight line. It's the shortest distance along the curved surface here. It targets to the top of this honey. Right? It can't go directly to the honey because it's on the outside. And then once it reaches the honey, it goes towards the honey. But it need not go directly above. It sort of cuts it here somewhere and goes like that. And the way to know exactly what it is doing is in this picture here. Now it's making from, there's your ant, right? It's on the outside. It's 2 centimeters from the bottom, and it goes a straight line. And this is the top rim, and you can see it goes to the rim. It doesn't go to the part which is it doesn't go here and go up there, right? You want the shortest distance. If it goes from here to there, vertically above, that distance can be beaten by going in a straight line, but you have to cut it at a slant like that. So this is the shortest distance. And now you need to know what these distances are. I've got this honey here drawn right in the middle because, as I told you, this thing is along the diameter. So when you're opening it out, you're opening it out so the cut is made along this line here. And that's why this end is here on the edge. And this is the cut. Right? It's just a little difficult. So now, so really, this part here is vertically above, and here this is the diameter. So it's halfway. The circumference, when you take half the circumference, you have to go to half the circumference. This is 6, right? And then this is the full length of the, but it's 2 centimeters at the top there. So it goes up to 6. The 6 here, so the whole thing is 8. There's 2 here. Up to this point here, it's 6. And From there to there, it's 2. That makes 8. I'm looking at a vertical line which is joining this honey to the bottom. Let me just put another color to this so you can see what's going on. So from the honey, I go down to the bottom like that, and then I'm drawing the diameter. But now the circumference is now becomes a straight line. So this part here becomes your base. So this is your 6 that we're talking about. And that is 8. Now, the distance here now becomes quite easy once you see all this. Because the shortest distance now is just simply using Pythagoras. Is the square root of 6 squared plus 8 squared. And this is 10. All right, so the shortest pathway from the ant to the honey is 10. And you notice we're actually traveling along a straight line here. It doesn't look as if you can ever go on a straight line on this, but it's you can. You can go on a straight line on this curved surface, right? If you open it out, you'll see how it is. Okay, so that takes care of question 11, and we now move on to question 12. So here, I give the full description of what's going on. If you didn't understand it, you can go and read this thing all over again. But we're going to go on to the next problem, which is question 12. And question 12, a diagonal is drawn inside a large square. So you got a square here. I see there are lots of questions on squares. It's the simplest of the quadrilaterals, and it's got the most amount of properties. So make sure you know all the properties of a square. All the sides are equal. All the angles are 90 degrees. That you know. But what's important is the diagonal. There are 2 diagonals. Either diagonal, it cuts this square into 2 equal parts. They're actually congruent, but they're right angle triangles. And they are isosceles triangles because all the sides are the same. So these angles are 45 degrees, 45. So the diagonal bisects the opposite angles to make each of them 45. Those are some of the properties of a square. Right, but in this particular problem, you've got a square drawn like this, so that the 4th point, 3 points are that 1 point is here, 1 point is here, and the 4th point is sitting along the diagonal. And you got another square which is the base is on the diagonal, and the other 2 points are on the sides. Okay, so now the question is, if the area of the blue square is A and the area of the pink square or whatever, what color is orange? The orange square is B, then what is the ratio of A is to B? So that's the question. Okay. Okay, let's start here. The area of a square is, I need to know the sides. Let's call this A. And so this becomes A. All the sides are A. And so the 4 sides are A. Now, this is the diagonal of the square, so therefore these angles are 45 degrees. So this angle is 45. So is this. A diagonal of a square, I just told you, it bisects The reason for that is you've got an isosceles triangle here, and this is 90 degrees. So the sum of these two angles must be 90, but they are equal. All right. Now, but now, yeah, if this is 90, it's a square, that is 45. So this has to be 45 also, right? Which means that this small white triangle is also isosceles because you got two angles are the same, and one side is A, so this side here is A. All right. So what does this mean? It means that the side of the original square is 2A. All these sides are the same. 2A. Okay, so when you start off with give a name to the side here, you'll see that this that allows you to conclude that the side of the large triangle, large square, is 2A. So let's get to the other one. Here I got B. Small b is a side of this. So this means that this is B. So all the sides are B. So this is B. Now, here you got 45 and you got this. This is also 45, right? Because this is 90 degrees here. If this is B, that means this from here to here, it's B. Okay, let me just create some space here. That angle is 45 degrees, which I just wiped out. So this length here is B. And this side here is also B because we let small b be the side of this tilted square. So from here to here is also B. But if you look at this triangle here, this is also 45. So even this is isosceles, and this side is B, so this is B. So you got the diagonal is 3B. B, 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 all of these are the same, right? So if small a is the side of capital A and B is small b is the side of square B, then A, which is the area of the blue one, over B is A squared over B squared. So I need to calculate A squared over B squared. All right, so is there anything that links up A and B? Now, we've actually drawn all this. And if you look at this, you see I've got a right angle triangle. This part here is a right angle triangle. One side is 2A, the other side is 2A. And the diagonal is 3B because the diagonal is split into three equal parts. So you got that from Pythagoras. This guy was credited with this theorem, but 1,000 years before him, it was already known. I think it was known to both the Arabs and the Hindus, but certainly it was known to the Hindus. Pythagoras' theorem, and you've got, it says that 2a all squared plus 2a all squared, this squared plus this squared is equal to 3b all squared. If you want to know a nice proof of Pythagoras' theorem, you can go and check my book also. I got a very simple diagrammatic proof, right? And it's a very lovely proof that the sum of the squares of two sides of a right angle triangle is equal to the square of the hypotenuse. All right, so this gives you the 4a squared. You got 8a squared, 4a squared plus 4a squared is 9b squared. So that gives you a squared over b squared. Be careful here. A lot of people say a squared over b squared is 8 over 9. Not equal to. Right? Be careful. Why? Because actually what you have here is you got 8a squared. When I put equals, you'll have to cross multiply. 8a squared is equal to 9b squared. See, 8a squared equals 9b squared from here. It's not 8 over 9, it's 9 over 8. So that's the answer. So the required ratio is 9 over 8. All right. Okay, let's now just get on to the next problem. And just, oh, I got, it's supposed to be 9 over 8. I don't know. Something wrong here. Oh, yeah, there it is. A over B is 9 over 8. Okay, I'm not sure what's going on here. Okay. Got 1 over x squared. X squared is 8 over 9, therefore 1 over x squared is 9 over 8. Okay, that's fine. So you get the same answer, and I've given you two different methods here to solve that. You can go and have a look at that. Now, let's have a look at the next problem. The next problem says that the diagram below shows you two lines which meet at A, at this thing here, and you draw a circle which touches both the lines, and then you draw another circle which also touches both the lines, but also this circle. And I think you continue to do that. Then you draw another circle which touches both these lines. You have to extend it and this. So you keep going on like this. And you can get larger and larger circles, incredibly large. So that's what is in this problem. But they tell you just one fact. They tell you that this first circle, the first one, BC over AB is a half. In other words, this height here is half the hypotenuse. And BC over AB is a half. Actually, using that ratio, you can calculate what this angle is. And it turns out this angle is actually 30 degrees, angle BAC. If this ratio BC over AB is a half, then if this is half the hypotenuse, then this angle will have to be 30 degrees. All right, now if you don't believe that, I'm going to just quickly, because I don't want to digress too much. If you start off with an equilateral triangle, and you split this thing into two equal parts, because it's an isosceles triangle. And if these sides were, if the side of the equilateral triangle is A 60 degrees, then this is also 2A, because, I'm sorry, it's A. But when you split this thing up, it becomes two equal parts. So this part here is A over 2, you see. And this angle here is 30 degrees. So you have a right angle triangle here. This is the same as the small right angle triangle here. Got an angle of 30 degrees. Well, I'm telling you it's 30 degrees, but the reason is when you take, you see this part here, the side which is opposite 30 degrees, that is equal to A over 2, which is half the hypotenuse. So they give you the side opposite that this angle here is BC, and that's half the hypotenuse. So this angle has to be 30 degrees. Anyway, I don't think that is important. We don't need the 30 degrees in trying to solve this problem, as we shall see. So what is really the problem? The problem is, it asks this question. If you keep drawing this thing, find the radius of the 2025th circle. You got the first circle. This red one is the first. This is the second circle, and so on in the third circle. What I do here is I don't look at just this. I take a random circle with radius r, and I construct another circle which touches this, touches that, and touches that. And I ask myself, what is the connection between the radius of this circle and the radius of this large circle? Right. This large circle, its radius is dependent on this one here, because this circle here touches this thing exactly, and it touches these two lines. So what is the connection between these two radii? So I call the radius of the large circle r, capital R, to indicate it's the large radius, and this one here is a small radius. I'm calling this r. Okay. They tell you that the original circle, the smallest circle, has got radius 1. This guy here has got radius 1. That is 1. Right. And it's a little circle here, which I'm ignoring for the moment. Right. I'm going to take a circle of radius r. Now, so is there a connection between capital R and small r? Can we find capital R in terms of small r? Now, I just want to notice something here. We've done this before, and you see, you got these triangles. You got, in two cases, you got this kind of scenario. $90, 90 degrees. When I say two, see, actually you got three. That and 90 degrees, the large 90 degrees. So there's an important thing about these triangles like this. The angles of the small triangle are the same as the angles of the large triangle. You can see that very clearly, because the small triangle, as long as this is perpendicular, the 90, right? And this angle is in both the baby triangle as well as the mother triangle. So you've got the large triangle and the small triangle. You've got 90 dot, so the third angle will be the same. So they got the same angles. And then we have said that then the sides are in proportion, right? If you've been looking at the other ones, if you looked at 2023 and 2024, I have similar sessions there. Then we said that if you got two triangles which got the same angles, then the sides are in proportion. What do you mean by that? It means that if you got a triangle like that, and you got another triangle which got the same angles. So if you call to say dot, curl, and cross, and here I've got dot, cross, and curl, got the same angles. And here if I got A, B, C, then if I call this PQR, then these sides are in the same ratio. What do you mean by that? It means if I take B, now B corresponds to curl in the small triangle, and in the large triangle, R corresponds to curl. When we say correspond, it means that the side is opposite the angle. In any triangle, the sides and the angles are paired, with a side and the angle opposite it. So B over R, if you take A, right, the ratio will be A over what? This is dot, it will be A over Q, because the side opposite dot is Q here. And likewise, C is opposite cross, and the side opposite cross is P. Right. So here we can do the same thing. In particular, I want to look at this side here, A over B, will be equal to this part here, which is opposite that curve, this angle here. And here in the large one, it will be that one. So it's this part over the whole thing, right? So this piece over this piece, the ratio of the heights is the ratio of the sides of these two triangles. This side over the whole thing, right? So bearing that in mind, I can have the following. I want to find this capital R in terms of R, but you can see I've got R, there it is. This height over that height is equal to this whole thing, AD. Oh, now it will be AD over AF. Right? That's the hypotenuse of the small triangle over the hypotenuse of the large triangle. Right. But now, can we find these in terms of small r? Well, what is AD? AD is actually equal to this piece here. It's equal to R plus AD. Oh, yeah, you see, we said that this is half that. Okay. So it means this side here is opposite, is half the hypotenuse. It means the same thing for this. This side here is half the hypotenuse. So if this is R, AD is 2R. Yeah, I'm looking at this one here. R over capital R is equal to AD, which is 2R, over the AF. Now, what is AF? AF is this length from here to here plus R. But the length from here to here is, from here to here, it's 2R. And here you got R itself, it's radius of the circle. So it's 3R, 3R plus capital R. Because that's the hypotenuse of this outside triangle. You got R here, you got capital R, and you got 2R here. So it's the full length is 2R, 3R, yeah, 2R over the hypotenuse is 3R plus capital R. So there it is. You have a relationship between these two, and if you cross multiply, you have R into 3R plus capital R equals 2R capital R. This is 3R squared plus capital R times R equals 2 capital R times R, 3R squared. Take this to the other side, and you have R, 2R minus capital R. R's cancel, and you have the outside radius is actually equal to 3 times this radius. So this radius of this new circle is 3 times the radius of the old circle. Now that's a very useful characterization. So whenever you have a thing like this, a circle which touches both this and another one which touches this as well, then you have that the large circle has got 3 times the radius of the large circle is 3 times the radius of the smaller circle. Okay, I just want to just digress a little bit, just hold on to that fact. And I want to say something about this thing here, the circle. How do you draw the circle? See? How do you draw a circle which touches two lines? If I got two lines, I got an angle created, and I say, draw a circle which touches both. Right. The way to do that is to bisect this angle. Right. Now I'm going to tell you why. When you bisect this angle, in other words, divide it up into two equal parts, right? Then let's call these two dots here like this. They're equal. Now, what happens here is that if I take any point on this, on the bisector, and I draw a perpendicular to this, and I draw a perpendicular to that one, any point, random point, this is perpendicular. If you compare these two triangles, you see they're congruent. You got a common side here. More than, you got 90 degrees dot, 90 degrees dot, but there is a common side. So you got three conditions. So you got two angles on the side, they're congruent, which means that these are equal. Right. Now, if I put my compass point here and I draw a circle with this radius, right, because this is 90 degrees, this line will be tangent to that circle. Right? This kind of thing occurs very often, and everybody should know this. All Olympiad students should know that whenever you have a circle and you've got a straight line which is tangent to it, so it touches the circle at a certain point. If you join this point to the center of the circle, right, it will be 90 degrees. It'll be 90 degrees. Right? So if you draw a circle, you draw a tangent, and you join, there's a point of contact here, a single point, and there's a circle which has got a single center, and you join that line segment that contains the point of contact to the center. That line is perpendicular to the tangent. Right? I'll just tell you very quickly, the reason for that is that this is the shortest line from this point to that line. Every other line is longer because it's going to be longer than the radius. This is the radius, and every other line will be longer than the radius. All right, so this is the shortest, and therefore the shortest distance from a point to a line is the perpendicular distance. Okay, that's the digression. And so this always happens. So this point here, and these two are equal, you see? R, and from there to there it's equal. So therefore this point lies, this angle is bisected here. So the entire angle, I told you earlier on this was 30 degrees. The entire angle is actually 60 degrees in this diagram. Okay. And this point, exactly the same thing. It's also be on the bisector. That is why this point and that point will all lie in the same straight line, because this straight line is the bisector of this angle. This point lies on the bisector, that point lies on the bisector, and the both of them will go through the point of contact. You see, again, I made a quiet assumption here in this diagram that this line here, the bisector, goes to the point of contact, and the reason for that is that this line here, there's a common tangent. When they're touching, the tangent to the small circle is the same as the tangent to the large circle, right? And I told you that the radius is perpendicular to this. On this side, you have a 90 degrees. If I draw this common tangent, then this radius, the 90 degrees on this side, and this side also there's 90 degrees, because this is the tangent to that circle as well. These two 90 degrees will be 180 degrees, so that becomes a straight line. So in other words, the when you join the two centers of these two circles, it will go through the point of contact. Okay, that's an important fact. Okay, now that's just a digression. Now to get back to our problem, we needed to work out what is the radius of the 2025th circle, which is the center is somewhere in the, near Mars or something. Right? Very, very far away. It's a huge circle. Let me see what's going on here. You see, so let's go back to the problem. Here, the first circle, R1, let's call that first radius, I call it 1, right? The first circle, and this is the radius of the first circle. The second circle, this is the second circle, its radius is 3 times that one, right? The third circle, the radius will be 3 times this radius. Each radius is 3 times the previous one. So that's 3 squared. The fourth circle will be 3 times the previous radius. It will be 3 cubed. Now you can see the pattern. So you're looking for the 2025th circle. It has to be 3 to the power of, when this the fourth circle, the index is 3. This third circle, the index is 2. So here it's 2024. So this is the radius of that large circle. Right? That's a very large number, right? I can tell you that this number here has got over 3,400 digits. It's got more than 3,400 digits. Now you might wonder, where the heck did Prof get this number from? That you can calculate that using logarithms. All right, that's another interesting subject. So let's get on to the next problem. We worked out the radius. We got on problem number 14. Now I did something very, very complicated here. You can just ignore this. Hopefully, at that time I was going to town with all kind of heavy mathematics. But you can see right at the end, I got 3,024. Okay, so that is the 3 to the power of 2024. So that is the answer to that question. Okay, let's get on to the next problem. The next problem is a classic game that was played hundreds of years ago in the taverns of England, involved 3 dice, right, marked differently, shown below. The pictures represent a net of each face. Now, these are the 3 dice. So the blue one, all the sides are 4. You can see the same thing. When you open it out, you get all the numbers on the sides are 4. And in the yellow one, you can see 2 1s here and a 10. But actually, when you open it out, you will see that you got 4 1s and 2 10s. And likewise, here you've got 6s. This is not 9, these are 6s. And you've got 4 6s and 2 0s. So when you throw a die, right? That's the singular for dice. When you throw a die, like this one here, it'll always show a 4. All the sides are 4. This one, it'll show a 10 sometimes and 1 sometimes. But since there are only 2 10s, it will show 10s probabilistically 1/3 of the time, because there are only 2 10s and there are 6 numbers altogether. So the probability of getting 10 is 1/3, while the probability is 4/6 for the 1. So the 1 will occur 2/3 of the time. And here also, you got 4 6s and 2 0s. So the probability of getting a 6 is 4 out of 6, which is 2/3, and the probability of getting the 1, 2 zeros, is 1/3. Okay, all right, now having got the story here, the game is simple. Player A chooses one of the dice, he takes any one of these 3 dice and rolls it. Right. Then player B chooses one of the other 2 dice remaining and rolls that. Now you'll notice that the total here is 4 sixes, which is 24. Here you got 2 10s, which is 20, plus 4, which is 24 again. And here you got 4 sixes and 2 zeros, that's 24. So all the totals are the same. All right. Now, so both of them roll it, and the player with the highest score wins. Right. So they play a game, the player with the highest score wins. Now, they say show that the odds are that the player who plays first loses. Okay, now this is not an easy problem. So let's, hopefully you understood exactly what it is. It's not difficult to understand what this thing is. All right. So what I do now is I want to calculate, the question is, the player who plays first loses. Right. Okay, suppose now A plays first. You don't know who they are. Suppose A plays first. Their names are not given, so we'll call them A and B. Okay, now this I call the small b for blue, and I call the small y for yellow, and I call the small. So these are the 3 dice. The 3 dice have also got names, B, Y, and R. Now listen carefully. The probability that A wins is what? See, if he plays B, he's going to get 4. And if B plays R will get 6 2/3 of the time, and you'll get 4 1/3 of the time. So 2/3 of the time are, if B chooses R, we are saying B is choosing R, the red one, then he's going to win 4 times. The 6 will beat the 4. So you'll always get 4 here. So the chances of the red winning is actually 2/3, and the chance of this winning 4 beating 6, it beats it only when there are 2 zeros. So this is 1/3, right? So the probability that A wins is 1/3, and therefore, this is supposed to be B, sorry, and the probability that B wins is 2/3, obviously, because A wins the same as saying that B loses. Right. So, and the 2 probabilities will add up to 1. Okay. Now, most of them are quite easy, but I just need to calculate some more complicated problems. But so suppose, let's just take a simple case. I say A has got, say, suppose you got a dice which has got, say, 7 7 2 and 6 6 3. I think it's 6 6 8. 14. Yeah, 6 6 2. 12 plus 2 is 14. 16. So 6 6 4. Okay. Now, in this situation here, right, what is the probability that the first guy wins? If you see here, you'll see that you can have when they're rolling the dice, you got to have 7, 6, that, and that. The next one is, you could have got this 6, or you could have got that one, or you could have got those two, 7, 6, 7, 6 again, and 7, 4, or you could have had 2, 6, 2, 6, and 2, 4. Right? And now you will see what is the probability of A winning. You will see that A wins here, he wins here, he wins here. 7, 6 again, he wins here, wins here, wins here. But he loses here because he plays a 2 and the other guy gets, he wins, right? So the probability of A winning is 6 out of 9. Which is 2/3. Right? So you see the way to realize that is if you place a 7, then he's going to always win. The 7 will beat all these numbers, and the 7 comes up 2/3 of the time, right? And it'll beat anything here. And this 2 here, it loses to everything here, right? And that is how the 2/3 comes in. See, so you have to. It's a bad example, but generally you have to multiply these two probabilities. Okay, I should have had a better example. And you'll see how it works. Like for instance, now if you take one moment, please. Yeah, if you take, for instance, this one here, right? What number shall I put here? The Y, suppose A plays Y. Now, he will win, Y will win only for, for when he throws a 10. So if Y throws a 10, that is 1/3 of the time, right? And that 10 will beat any of these. So if he had a 10, it'll be 1/3 of the time. Now the thing is, 2/3 of the time he plays a 1. And the 1 beats the 0, you see. And the 0 occurs 1/3 times. So here you'll have to work out, he wins all the time here, 1/3. But when he plays a 1 2/3 of the time, each time there's a 1, right? Only 1/3 of the time it'll beat this. So this here is 1/3 plus 2 ninths, and that is 5 ninths, right? When you add these probabilities. That's a little bit tricky, but think about that and you will see why. In fact, you can try out small numbers. I chose a bad example, and you will see what happens. Okay, so if you work out all these probabilities, this is what you get. This is 1/3. Let's write this thing clearly. This is 1/3. This is 2/3. This is 1/3. And this is 5/9. I just worked this thing out. I worked this thing out elsewhere, and now I'm looking at my answers, which I'm holding in my hand. I don't want to go through all this. You can try to do it yourself. And this will be 1/3. You must add one. Both of them add up to one because the loss of one is the win of the other. Right. Now, so we know the probability for each case. If A picks a blue, or if A picks a yellow, or A picks a red, then you know exactly what are the chances that he is going to win or lose, right? In some cases, if the probability is less than half, that means the chances are he's going to lose. But it's more than half, then he's got a better chance of. He's got a chances are that he's going to win. All right. So bearing all that in mind, the first question says, show that the odds are that the player who plays first is going to lose. Now, how can that be? All right. Suppose I am playing you, right? So I throw I throw A throws B. Suppose A throws B, then the chances of him winning are 1/3. Now, what will B play? B has got a choice. So A chooses B. So B knows that his chances of winning are A. So what he will do is he will choose he will choose the red because the red beats that. B will choose red. Then he's got a better chance of winning. So A will lose if he chooses 1/3. If he chooses blue, then B will choose that. You see, he'll choose red. He wouldn't choose yellow. If B chooses yellow, then you've got BY, and then he's got then B will lose. You see, because then yeah. So if A chooses B, then blue, then B will choose red. Now, likewise, if A chooses Y, A chooses yellow, then you've got 1/3 and you've got 5/9 here. Right? You will win with this, but if he chooses yellow, then what then what B will have to do is to choose B because then is B will beat him, right? If he chooses yellow, it'll be 1/3 probability then. So then A loses. A loses here as well. So you see, B has got a choice. And then if A chooses the red, if A chooses the red, right, then the 4/9 is smaller than 5/9. So B will choose yellow. So in each case, B will choose one of the colors which will beat the choice of A. So that is why they show that the odds are that the player who plays first loses. He wouldn't necessarily lose, but the chances are that he will lose. There's a 2/3 probability that he will lose. It's not 100% probability. 2/3. That means the odds will favor uh, B. In all these three cases, the odds will favor B. So therefore, they say the odds are that the player who plays first loses. All right. Okay, so that's the first. It's a difficult question to understand. And then the second question is, if a player does play first, what is his best strategy? So suppose A plays first. Now that means what must he choose? What must he choose? Which color must he choose if he's playing first? So if you think about that, again, if you look at this table, you will see that suppose A chooses yellow, right? His chances of winning are 4 nines. If he chooses red, it's 5 nines. And if he chooses yellow again, it's 4 nines. So if the best possibility for him is to choose the red. You see? If he chooses yellow, the best one is that he has to choose the red because the red will beat the yellow any day. Right? Okay, so you can try with each one of them. You can see that, yeah, because he's got the best chances of winning. All right, let's get on to the next problem. Happily, this is the last one. So A's best chance, the last line is to choose red. Okay. This was quite a difficult round three. Okay. You see, the thing is, there are some very good students around the country, so you have to give them some very challenging problems to identify the top student in the whole country. So there has to be some challenging problems. You are given 4 hours in round three, so you got enough time. But the problems are hard. Now look at this. Given that 1 plus x squared and so on, you got plus dot dot dot. In other words, it goes on indefinitely. It's actually an infinite sum, this, because it doesn't end anywhere. Right? So given that this is equal to 2, now find the value of this one here. So we need to calculate this s, and this is equal to 2. Okay. Now, so what is s? Now you'll notice here I got 1 plus x squared. I got all powers of x, and I know that this thing all adds up to 2. And here I don't have powers of x. I've got powers of x certainly, but I've got the coefficients are 1, 2, 3, 4, and so on. Right? Now the trick here is actually to multiply s by x. Let's put a 2 here on this side. And what I'm going to do is, you'll see why. I'll, I'll work out x times s. No, I'm sorry, x times 2. Sorry, I'm just looking for the. Okay, so I'm going to multiply. I'll try to get an x in the front. So you got 2x equals, you multiply everything by x. Like that. Now I'm going to write down s here again. S is x plus 2x squared. I'm repeating this. Plus 3x cubed plus 4x to the fourth No, I'm sorry, that's not going to work. Um, Sorry, I seem to have forgotten how this goes. Yeah, don't worry about the 2 for the moment. We'll take S. Let's write S here. So I've got S is equal to X plus 2x squared plus 3x cubed plus 4x to the fourth plus etc. I'm going to multiply S by X. Right. So when I multiply S by X, then I'll have X times X, which is X squared. And I'm going to put the X squared underneath here. Now I'll multiply this by X. I get 2x cubed. I'm going to put that underneath the cubes here. So X times this. And X times this, I'll get 3x to the fourth. Right. Now, what I do is I subtract these two. And the reason for that is when I subtract, I get X. This minus 2x squared minus x squared is plus x squared. 3x cubed minus 2x cubed is x cubed. And 4x to the fourth minus 3x to the fourth is x to the fourth. Now you see, this is very similar to this part here, right? And this whole thing is 2. So therefore, this part here onwards, that's what I got here, right, is going to be equal to 2 minus 1. So that's 1, right? Because you got on the left-hand side, you got 2. If you take 1 to the other side, you got 1 is exactly equal to this. So S minus Sx is 1. So you got S into 1 minus x is equal to 1. So therefore, S is equal to 1 over 1 minus x. But that still doesn't give me the answer. I need to see what is the value for x here. Okay, so just hold on with that. Let's focus on this guy here and see what happens. I'm going to rub all these things out. I'm going to focus on this. The first equation. I've got 2 is equal to 1 plus x plus x squared plus x cubed. I do the same thing what I did to the other one. Multiply on both sides by x. I get 2x. X times 1 is x. X times x squared. X times x is x squared. X times x cubed. X squared is x cubed. And so on. Now you'll see here that this part, as we saw before, is 2 minus 1. It's 1. So you got 2x equals 1. So therefore x is equal to a half. So you actually calculated what the x value is. So the interesting thing is when you take 1 plus half squared and so on, you're going to land up with 2. All right, so x is equal to half. So that allows you to calculate the value of s. That's what we need because x is a half, right? 1 minus half is a half at the bottom, and that is 2. So s is also 2. So s, this one here is also 2, just like x. And this all belongs to a subject called infinite series. It's quite a difficult subject, but there are some questions. How can you add an infinitely many numbers? And if all of them are positive like this, You'll have infinitely many positive numbers. How can you have that equal to 2 and so on? So there are lots of funny looking questions that you can ask around this, but it all belongs to a very rich mathematical theory called the theory of convergence of infinite series. All right, but whatever, this is how you make the calculation for S. Okay, thank you very much. That brings us to the end of the junior round 3 2025 paper. I've just worked out the problems from 9 to 15. In another uh, recording, I would have had the problems from 1 to 9, right? Or sometimes maybe all of them have been merged, but whatever, those problems have already been recorded, those solutions. So you can find them somewhere in the internet. Thank you very much for listening.